All right, ladies and gentlemen, welcome back. So the last video I mentioned very briefly that when we look at the pathways for metabolism, they are very much these redox reactions when we look at the overall pathway. So what does that mean? So when we take a look at that term redox, it's really looking at reactions where certain compounds in that reaction are transferring electrons to somebody else. All right, so we're transferring electrons through that chemical reaction that releases energy stored in those organic molecules. And that ultimate release of energy is going to be utilized to then synthesize ATP in the case of cellular respiration. So when we look at this, one compound in the pathway or in the reaction is going to become oxidized, the other is going to become reduced. And that's where that term redox comes from, reduction and oxidation. So if I look at just a really simplistic, easy way to see this, is the creation of salt. So that sodium atom here becomes oxidized. It loses its electron, and so overall it has a more positive charge because it's lost that negative electron. The chlorine, on the other hand, becomes reduced. It gains that electron from the sodium. As a result, it now becomes more negative. So when we look at these terms, when we talk about oxidation or something being oxidized, this is the substance that loses its electrons. So in this case, the sodium, right? And it's going to gain a more positive charge as a result. When we look at reduction, this is the substance that's gaining electrons. It's being reduced. And as a result, it's becoming more negative. So when we look at these, in the ions, it's really easy to see. When you get into the actual compounds where there aren't obvious charges, then we have to start looking at what atoms are being moved around and the electrons that are being shuffled with them. So just a quick general way to kind of remember what this means, to remember oxidation and reduction and who's gaining and losing, there's this kind of cutesy little saying called Leo the lion goes gur. And the Leo part is lose electrons, oxidize, right? And the gur is gain electrons, reduce. And then you just need to remember, well, if I'm going to lose electrons, that means I'm losing negatives. And so overall, it's going to increase its positive charge. The gaining of electrons are negative, so I'm becoming more negative as a result. A couple other terms you may come across with this are the terms reducing agent versus oxidizing agent. The reducing agent is the electron donor. So it's reducing the other compound by accepting its electrons. All right. In the case of an oxidizing agent, the electron acceptor, and it's oxidizing the opposite by removing its electrons. So when I look at this, this is typically terms that'll be used in your reactant side of things. So the reducing agent in this case is going to be the sodium because it's donating its electrons to the chlorine. The chlorine is the oxidizing agent because it's being the electron acceptor. So when we look at things like those ions, it's a complete oxidation or reduction pathway. Not everything completely exchanges those electrons, but changes the degree to which the electrons are being shared. And that's what you're seeing here in this diagram. So I've got a methane, which is a reducing agent, and it's shifting the way it's sharing its electrons to become the carbon dioxide molecule. The oxygen is the oxidizing agent, and again, it's shifting the way it's sharing electrons when it becomes water. So it's really easy to identify redox processes when you're looking at ionic compounds because it's a complete give up or complete take. It does get a little bit more confusing when you look at the covalent compounds like this. So you have to understand, am I talking about a completely nonpolar molecule? Am I talking polar? Am I talking polar bond, even though the overall compound doesn't have a charge? So it definitely gets a little more complicated. As far as I'm concerned, for us right now, I just want you to be aware that that redox process occurs and that electrons are being moved, because it's going to impact the way that we look at these things called electron carriers when we actually get into the process of cellular respiration itself. So I'm introducing the concept of redox processes here to you. I'm not necessarily expecting for our purposes this year that you can look at a chemical reaction like this and be able to tell me which is being oxidized, which is being reduced. I'll leave that to your chemistry teachers. Um, but I just want you to recognize what the basics are, that a redox process exists, that somebody's gaining, somebody's losing, and kind of the basic vocabulary back here. Okay, so don't get lost in this. Pull what you can out of it so that when you see this again in the future, hopefully it makes a little bit more sense the next time around. So when we look at this cellular respiration process, right, and where does this fit in terms of redox? It's the overall process, the overall chemical formula that we're looking at here, where we can really point to the oxidation and the reduction. So the glucose is ultimately going to become oxidized, right, when it becomes that carbon dioxide. The oxygen is going to get reduced into water. All right, and so again, it's the moving of electrons that are going to happen really all in the middle here. There's lots and lots of chemical reactions happening in the interim to get us from that oxidation and reduction process to see this overall pathway.